Welcome to the Georgia Department of Education Professional Learning video series. This video is specifically designed for 4th grade math educators. The focus standard for this video is NBT 6. The objective of the standard is students will find whole number quotients and remainders with up to 4-digit dividends and 1-digit divisors. The important thing is to focus on the strategies of division as opposed to teaching students mnemonics for the standard algorithm for long division. Students in grades 3 through 5 focus on the concept of division and strategies. Each year, a layer is added until finally in 6th grade, students learn to fluently divide multi-digit numbers using the standard algorithm. Notice that the only real difference between 4th and 5th grades is the size of the divisor. This gives students 2 solid years of practice with meaning-based strategies before they learn the standard algorithm in 6th grade. Before we get into our strategies, let's address a few misconceptions. Learning the standard algorithm for long division is a 6th grade standard. Without a foundational understanding of division, students must rely on rote memory, which can leave room for careless errors. Another misconception is the number with the greater value is always the quantity that is being divided. This isn't always the case, particularly when interpreting a fraction as division. For example, 1 pizza can be divided among 4 people so that each person receives 1/4 of the pizza. So 1 divided by 4 equals 1/4. The third misconception is that division always produces a quotient that is less than the dividend. However, when using divisors that are less than 1, it is possible to get a quotient that is greater than the dividend. For example, 4 cookies divided into half-size pieces will result in 8 half-size pieces. Therefore, 4 divided by 1/2 is 8. One last thing before we get into our strategies. It is important for educators to be aware there are 2 types of division. While students do not need to articulate the type of division they are working with, understanding the 2 types can help them with the process of problem solving. The defining factor that separates the 2 types of division is the role of the divisor. The divisor can either reveal the size of the group or the number of groups. We will take a look at strategies using the 2 types of division, but going through a progression of concrete to pictorial to abstract. In the following clips, you will see students solidifying their understanding of division with hands-on models, illustrating those models with a picture, and finally, using an algorithm that builds on their understanding. In this clip, you will see the student using a concrete strategy and measurement process to yield a result for this division problem. She is using discs and place value understanding to create groups of 5. As she regroups the leftover discs in each place, she remembers 1 disc represents 10 times as many as a disc or digit to its right, which reiterates academic language from NBT 1. In this pictorial strategy, notice how the student is building on the concrete model from the previous clip to now create a representation of the discs. The student is drawing a circle around his group of 4, which makes this a measurement process based on place value understanding. Notice the student draws arrows to indicate 1 disc is 10 times as many as a digit to its right, which again draws upon understanding of the NBT1 standard. This concrete strategy also stresses place value understanding because the student is fair sharing equal groups and making fair trades and regrouping as necessary. Notice he first regroups the cube into 10 flats, divides them out, and then divides out the units before regrouping the remaining flat. That's okay. He is solidifying his understanding of division and applying his understanding of place value and regrouping to model his solution. At the end, he organizes and counts the blocks to ensure each group has an equal amount. He removes the extra unit, which he interprets to be his remainder. This strategy also shows students how multiplication can be used to check your work. This pictorial strategy is a visual representation of the partition strategy from the previous clip. The student starts by drawing 3 circles to represent his 3 groups as indicated by the divisor. At the bottom, he has drawn how a flat will be regrouped into 10 rods and 1 rod will be regrouped into 10 units. Crossing out what he has distributed helps him keep organized in his work, but he does need a reminder at the end that a remaining rod needs to be regrouped and divided out. In this abstract strategy, students must rely on their understanding of multiplication and division to conclude the quotient using the partition process. First, the student draws 3 columns to represent his 3 equal groups. He distributes 50, but changes his mind to distribute 100. However, it would have been completely acceptable to begin with 50. Each time he distributes an amount, he must multiply or add and then subtract to determine how much of the dividend he still has left to distribute. Once he cannot distribute any more, he adds up the total amount in a column for his quotient. Leftovers from 100 is a rich task from Marilyn Burns. In this 2-person game, student 1 starts with 100, selects a divisor, and solves for the quotient and remainder. The remainder is subtracted from 100 and becomes the new starting number. Student 2 selects a different divisor and solves for the quotient and remainder. This pattern continues, but the game ends when the remainder is 0. Then, students add up their respective remainders and the student with the highest total wins. Let's see a bit of this in action. Be sure to pay attention to the student strategy and notice there is a calculation error in the second row. This is a great opportunity for students to engage in the 3rd standard of mathematical practice.
9, and 9 times 10 equals 90, and I have 92, so I have a remainder of 2. So division expression is 92 divided by 9 equals 10 remainder 2.
Lastly, here is a free tool that students can use to model division with partial quotients and an open array or area model. They can even type in word problems. This is a great way to incorporate technology and virtual manipulatives into your classroom. By doing so, students have the opportunity to exercise standards of mathematical practice 4 and 5.